Welcome everybody to this talk, and thanks again for the introduction. I'm happy to present a work which was published several months ago on a smart glove we built in Dresden. And I want to start with giving you some context, because this work is part of the Center of Excellence, CETI, and CETI means Center for the Tactile Internet with Human in the Loop. Now, what does it mean? When we started the cluster, we observed that the internet today is an internet of knowledge, and we wanted to take steps to make it an internet of skills, where we really can convey not only knowledge, but also skills. And one part could be that you have an expert on one side, and he is or she is teleoperating a robot somewhere in the distance, and thus she could teach this robot something, or she could perform a difficult task, whatever. But this is only made possible if we have audio feedback, if we have video feedback, and if we also have tactile feedback. And then you're really in a domain where you're discussing ultra low latencies and stuff like that. So that's the idea of the Tactile Internet and our cluster. And one technological puzzle piece is this sensor glove, which I'm going to present. And from this perspective, we are talking about a sensor glove who has to be, of course, precise and accurate. That's clear. It has to be of ultra low latency. It has to be completely wireless. But it also has to be comfortable and easy to use, because in this cluster, we're cooperating with working groups of psychology and medicine, and they really want to use this glove for performing user studies. So it just won't cut it if you have a golden lab demonstrator. You really have to have several samples. You have to give it to them, and they will put it to the test with untrained personnel. So that means we have to minimize the size of the electronics. We have to get energy consumption down, and we have to make several dozens of these gloves. So these are the constraints we are working with. And in the center, we are organized in what we call talent pools. And I have the honor to coordinate the talent pool Tactile Electronics, which is comprised of 5 working groups. I myself, by trade, I'm an analog integrated circuits designer. We have digital integrated circuits designer. We have electronic packaging guys, we have software and operating system knowledge, and we have, of course, textile machinery. And what I'm going to present today is this version of the glove, which is very much a work in progress at the time. The interesting part of it is that the sensors itself, they are completely integrated within the textile. So they are made of a conductive yarn, and they are produced. This glove is produced in one automated step with the sensors already embedded in the structure. And this makes the sensing element ultra low profile. And since it's so well integrated, the sensor signal is also very nice, because you have a nice conformity to the fingers. So yeah, let's have a look at it. So I already talked about the sensors. So basically the gloves are produced in a knitting process, and the sensors are a polymer-based yarn with a silver iron coating. And yes, as I said, they're knitted inside the glove. And then we have this sensor front end, which consists of a sensor interface. Of course, we have a processing unit, we have a wireless interface, and we have some battery and charging circuitry. And let's have a closer look on the electronics part. So the sensor interface itself is really nothing special. It's a simple bridge. It's a resistive strain sensor, basically. So we just had to find a good compromise for the resistors to make it low power and still have a good sensor signal. We have an op amp to get it to the ADC requirements, and then we have a 12-bit ADC for each sensor. And we used an ESP32 SoC with a wireless interface, mainly because it's very widely used, and we can give this glove to anybody, and he or she would just know what to do with it. We have charging circuitry and the USB interface, of course. And we have this LiPo battery, which provides, at this stage, some 6 hours of autonomy. So now we had this glove, and we really, at the beginning, we didn't know how to qualify it because there are no standards. It's really quite not that easy to qualify a sensor which relies on a human motion. So you have to define some ways. What we did was we defined some simple gestures. So the first one was to count with your fingers, and we had a look at the raw ADC values. So this is without any processing. So what you see here is the signal over time for all the 5 ADC values. And what I did was to do like this, and then open the hand again. And you see this motion over time. So basically, this is where the thumb was bent. This is where the index was not bent. This is where the signal is not quite okay for the middle finger, but still readable. And these are. So we did this for discounting gestures. And we found we were really surprised by how good the sensor signal actually was, and also how stable it was over time. And then we wanted to distinguish a grabbing motion. So I started again with an open hand, then made a fist, then opened it again, and then made a gripping motion. And this also could still be detected in the measurement signals. Okay, so this was quite okay for a first prototype, but as I said, this really was not ready to be done studies with. So we had difficulty of fixing the electronics to the textile. Also, the interface between the yarn and the electronics was a huge challenge because it was just not reliable. So this is the next version of the prototype, which already looks a lot nicer. We have sort of a pocket for the electronics. And what we did then, we built an virtual reality avatar of the hand, where we also, I forgot to mention it, that on the back of the hand, we also have an IMU. So we can not only sense the finger motion, we can also sense the hand position, the orientation, and the displacement. So now we had this virtual hand, and we could approach other working groups and show them, okay, this is what we can do with this glove. What do you have any idea with it? And several of them started to use it. Like this is an image of a remote operation demonstrator where we control a robotic hand with it. We have some gesture recognition, and at the moment we are in the process of building several dozens of these gloves, which in a university context is challenging. Let me put it this way. So a short outlook, what are we going to do next? So we still want to validate this sensor. And here, I think we are going to take 2 approaches. First, we are going to build a robotic hand where we can give a certain gripping angle, and then we can read out the value, and then we can qualify the sensor, and we can use this data to, in the future, pre-distort the sensor signal in a way. But the exciting part is that we can also do it the other way around. So I want to find some psychologists to make a study with me, and I will, with the virtual hand, show users a certain gripping motion, and they would mimic it. And then you can also qualify the sensor. And this would really be with the human in the loop, and which would be a lot more useful actually to compared to taking this classical engineering approach, I would say. What my working group is researching on is to have an ASIC integrated with the sensor front end and the wireless front end, because what you saw now is still the electronics are quite big. This is all commercial components. So we want to get it down by a factor of 20. So then in the end, really the electronics will vanish from the user's perceptual horizon. And we also want to reduce the energy consumption, because ultimately you're limited really by the battery. We have really exciting work in the electromechanical heterointegration sort of things. So we have a research group who's working on thinning the ASICs and embedding them in a polymer structure, and printing stretchable interconnects and stuff like that. And this will all finally be part of this graph. And we need more sensors, because at the moment we only have the banding. We have not the abduction of the thumb, which is really important. We do not have the Spock thing. So several things are still missing, and we are striving to integrate them. Yes, and we really want to team up. We started already to team up with psychology and medicine, and this is a picture of a recent first test in an experimental surgery room we have at the cluster. And the surgeon, as you see, is wearing the glove, and we want to try to use it to convey surgical skills to students in a novel way. Yeah. So thank you for your time. This is